Hello and welcome back to Friday Minis. Now, on Wednesday, we took a look at how we could use a sort of scanning technique to display any arbitrary image on a grid of LEDs. Now, did you know that the exact same technique can also be used to scan for inputs? Well, if you think about it, it kind of makes sense. It's fairly intuitive. If you have a bunch of switches laid out in the same fashion as we had, our LEDs, what you can do is you can send a high in along one of the rows and then basically see which columns actually have that high coming back. They'll only come back when the relevant switches are being closed, right? Because it creates a closed path, allowing electricity to flow that way. Even if we have just, X plus Y pins, we can scan X times Y number of buttons as long as we go row by row, or column by column, really, depending on how you want to do it. One example of this is with a numeric keypad. Those are laid out in more or less a grid pattern, and yeah, you could of course create context for every single button, but it makes a lot more sense to have it in a, sort of row column kind of format. Another example of this in use, well, is actually your keyboard on your computer. Now, not all keyboards use this. In fact, what is known as mechanical keyboards actually have, a switch for every single button. That's what makes them so expensive, well, at least part of the reason. And the thing is, if we don't do things that way, if we have just, a grid of wires that are being scanned, this could result in an effect known as keyboard ghosting. Now, I'm not going to talk too much about this since we have, kind of discussed ghosting before, but what I'm going to do is I'm going to try and visualize what is really happening when you press a bunch of buttons. Now, let us begin by starting simple, by just looking at what would happen if we have two keys pressed down. At its basis, it seems fairly straightforward. We can continue to scan our first row, and that would basically allow the voltage to come back on the second column. However, something unexpected happens. Now, because we are not scanning this row at the moment, we set it to the low state, and in other words, it is actually connected to ground. Now, this creates a problem because this switch being pressed down connects this line, which is high, to this line. So in fact, an unexpected side effect that is happening here is a sort of backflow of current. Now, this can be very bad because, well, if we are not actually expecting current to come back at this pin, this could easily fry your microcontroller. So yeah, there is an additional consideration to be made here. Of course, an additional problem that comes about with this is keyboard ghosting. In order to understand this, let's press down one more key and see what that creates for us. Assuming that we are able to account for the backflow of voltage and so nothing will get damaged, well, the readings will still be off, like so. When scanning the first row, of course, well, that column gets powered up, but there is a backflow of current. In fact, so much so that it goes down and basically raises this pin to high as well. Of course, you don't know that this is happening, so from the point of view of the microcontroller, all we know is that we are setting this row to high, and in response, these two columns are becoming high. So what I would assume is two buttons are being pressed down side by side. Now, this clearly is incorrect because this button was never pressed down. So this is the idea behind ghosting. We can get some incorrect readings as a result of, well, all those stray backflow of current. There are two ways of preventing this from happening, either to, have a set of pins for every single button, or to simply have diodes for every single button to prevent that backflow of current. So yeah, this is kind of interesting because, well, one concept we've learned, for LEDs, can easily be applied in a slightly different manner for a completely different application, as in this case, with a set of switches. So hopefully this goes to show that, base concepts like the whole scanning thing on a grid is something that can be applied very broadly. Anyway, that's basically all there is for this episode of Friday Minis. I hope you gained some insight today. Hopefully this was, kind of eye-opening in that respect. But yeah, that's it. Thank you very much for watching, and until next time, you're watching 0612 TV with NERDfirst.net. Thank you very much for watching. If you like my work and are feeling generous, you can shoot me a one-time donation on PayPal or sign up for a recurring one on Patreon. Of course, you can simply like, comment, and subscribe. You know the deal. For more videos, links to my channel and a related playlist are on screen. Thank you for your support.